Alright, welcome back to Anton Math. Now in this video we're going to talk about how we can create a parametric equation when we're given information about the curve. So we say finding parametric equations for a curve. Now we can use the geometric properties of a curve to describe it parametrically. So let's take a look at some examples. Let's say we want to find the parametric equations for the line given. So first, let's say we're given the information that this line has a slope of 1/2 and the line is passing through the point 4, -1. Now a slope of 1/2 means that if y increases by 1, then x increases by 2, and I can use my initial point as well to do these parametric equations. So I want to set up my parametric equations. When t equals 0, I want it so that my x is 4 and my y is -1. Okay? Now I need to set up my t in a way such that when t increases by 1, x increases by 2 and y increases by 1. So I'm just going to set it up this way. I'm going to say that I'm adding 2t to x and t to y. So now every time t goes up by 1, x goes up by 2 and y goes up by 1. Now let's go ahead and we can always check our answer by removing the parameter here. This is just a way to check, but these are the equations that we want. And there are other versions of this as well. Of course, I could have put t here and 1/2 t here, and that would have been the same thing, wouldn't it? But just checking to make sure that we pass through this point, and we have a slope of 1/2. Notice that my y is equal to -1 plus t. So that means that t is equal to y plus 1. So I can plug that in now for my parametric equation for x. X is equal to 4 plus 2t, where t is y plus 1. So I get that x equals, well, let's say 2y first, plus, and now I have this 4 plus 2 times 1, which is 6. And now let's throw that 6 to the other side, and I get 2y is equal to x minus 6, or y is equal to 1/2 x minus 3. Now we have the right slope here because we have a slope of 1/2, and let's plug in x equals 4. When x equals 4, y is going to be 1/2 of 4 minus 3. So this is 2 minus 3, which is indeed -1. So this line passes through the point 4, -1, and it has a slope of 1/2. So we have the correct parametric equations here. All right, let's take a look at another example of this. Let's look at the line passing through the points 6, 7, and 7, 8. Now we can start the same way, but I can choose either of my points to act as my anchor. So let's just say that when t equals 0, I want to be passing through the point 6, 7. So my x value is 6, and my y value is 7 when t equals 0. Now I need to figure out what increment of t to add to each of these parametric equations so that I also pass through 7, 8. But notice that when I go from 6, 7 to 7, 8, my x is changing by 1, and my y is also changing by 1. Right? So I'm changing the same amount in x here, changing by 1, as I am in y, aren't I? I'm increasing by 1 in both of them, so I can simply write plus t for both of these equations. Right? When t equals 0, x is 6 and y is 7. And when t equals 1, x is 7 and y is 8. So I'm passing through both of these points on the line given by these parametric equations. All right, short and sweet. Now that's the end of parametric equations for the most part. I am going to do one more video talking about modeling circular motion. This is something that can be helpful and sometimes comes up in homework in certain classes. So stay tuned and we'll see you there.